In this video, we continue on our journey of graphing sine and cosine functions, but in this particular video here, we're going to have a look at how we can graph functions that have undergone both amplitude and period dilation, as well as vertical and horizontal translations. So consider if we have a function y equals 3 sine 2 times t minus pi on 4 and plus 2. This particular function, it is of the form y equals a for amplitude, sine, then in parentheses, n, t plus or minus epsilon plus b. And breaking down this particular form, as seen with, say, that's the amplitude. This is our period dilation factor. Then we've got our horizontal translation, and then finally we've got this vertical translation. So what we're going to find is the amplitude and the period dilation. It affects this particular function, or the look of the function, in that it compresses and stretches the function about the x and y axes. And then we've got these new components, so the horizontal translation epsilon and the vertical translation b. So the way in which this works is for positive values of epsilon, we shift everything to the left, and for negative values of epsilon, we shift everything to the right. Similarly, for the b, for positive values of b, we shift upwards, and for negative values of b, we shift downwards. So, to have a look at the behavior of this, I've got on Desmos our graph here. So we've got this form here, y equals a sine and t plus phi in exchange for epsilon, because I can't get epsilon in Desmos, and then this plus b. So notice with the amplitude dilation, it's going to behave exactly how we saw in the previous videos, and the period dilation similarly as well. So we're dilating our period. But what about the epsilon here? So notice that with our epsilon, if we have negative values, we're going to shift everything to the right. So we're right of our y-axis. Notice the graph is starting on the right-hand side. And then for positive values, we're going to shift everything to the left. So left of the y-axis. So putting that on play, what you can see is as we go from negative to positive, we go from the right side shifting back to the left side. Now similarly, for the vertical translations, for positive b, we're going to raise our graph. Here we go. Positive b, we're lifting it above the x-axis, and for negative b, we're lowering it below the x-axis. So if we go to graph the function in our original example here, 3 sine 2 t minus pi on 4 and plus 2. So we've got an amplitude of 3, so notice we're dilating it up. So it's going to be, the top is going to have a maximum of 3, and the bottom is going to have negative 3. Now we had an amplitude or a period dilation of 2. Then we had a horizontal shift of negative pi over 4. And then finally we had a vertical translation of b equals 2. So notice the key features here. The graph, where it would usually start, so 0, 0, it's now been translated to pi on 4, which is the value of our epsilon, and it's been at y equals 2. So the value of b, and at one cycle, which is equal to pi in this case because we've dilated by a factor of 2, it's going to finish up the one cycle at 5 pi over 4, so pi plus pi over 4. It's going to have a maximum at 5, which is equal to 3 plus 2, or you could say the amplitude dilation of 3 plus the vertical translation of 2, and a minimum at 2 minus 3. And then its midpoint here is going to be 3 pi over 4 at 2, so B. So this is the behavior of what we would expect a function that's been both dilated in the amplitude and the period, as well as translated along the x and the y axes.